All right, in this question, we're needing to find the general solution of cos 4x plus cos 2x equals 0. Now, if we had been in methods, we wouldn't be able to do this because we can't change our domain. Cos of 4x is not equal to cos of 2x, so I can't simplify it. So I need to use another method. If I can get this to go from a sum to a product, maybe then I can use my null factor law with my two different angles, similar to the example we did a few examples back, and I can get my multiple solutions. So maybe we should try something like that. So what I've got is I've got cos of 4x plus cos of 2x is equal to 0. And I know I've got that identity that's cos of A plus cos of B. So using cos of A plus cos of B, so in this case A is going to be 4x and B is going to be 2x, okay? And that's equal to 2 times cos of A plus B over 2 cos of A minus B over 2. So that means what I've got, so let's let A equal 4x, B equal 2x. So then what I've got is that 2 cos of 4x plus 2x over 2 cos of 4x minus 2x over 2 must equal 0. And that gives me 2 cos of 6x over 2, which is 3x, cos of 2x over 2, which is just x, equals 0. Now hopefully you can see this is a null factor law. I'm multiplying this by this term. So by the null factor law, we have cos of 3x equals 0, or cos of x equals 0. And in this case now, they haven't asked us for a solution within a domain. They're asking us for the general solution. So the general solution is going to involve multiples of pi. Okay. Let's have a look at the first one. So 4 cos of x equals 0. Well, cos of x is equal to 0 when it's a boundary value, so when x is equal to pi on 2 or 3 pi on 2. Okay, so that's a boundary value. So it's going to be when x is equal to, excuse me, pi on 2, 3 pi on 2, 5 pi on 2, etc., etc., etc. These are all odd multiples of pi on 2. So we're going to get an odd number. We need 2n plus 1, okay, times pi on 2. Okay, and as soon as we've got an n, we're going to say n is a real number. So that's our first solution. And then let's look at for cos of 3x equals 0. Well, again, we're looking at our boundary value. Okay. But in this case, it's going to be that 3x is equal to pi on 2, 3 pi on 2, 5 pi on 2, etc., etc. So that means that 3x will be an odd multiple of pi on 2. So 2n plus 1 times pi on 2 where n is an integer. And that means that x is going to have to be 2n plus 1 times pi on 6. So that's my second lot of solutions. And then I'm just going to put them together. So x will be 2n plus 1 pi on 2, 2n plus 1 pi on 6, where n is an integer.